Alright, so in a real world scenario, there will be multiple features and bugs being worked on in parallel. In a situation where there are several engineers involved in building a product, you cannot expect one engineer to wait for the other to finish writing their piece of code. It all needs to happen simultaneously, but at the same time, this could also create problems. If everyone edits the same piece of code simultaneously, there could be unexpected overrides, dependency issues, and many other complicated problems. To solve this problem, Git has a concept of branching. Branching essentially means diverging from the main line of development and continuing to do the work without messing with that main line. So if 3 engineers are working on 3 different features, each engineer will create a branch and simultaneously work on their respective features without polluting the main branch. Once they are done with their feature, they can merge their branch with the main branch. To really understand the way Git does branching, we need to take a step back and examine how Git stores data. So essentially, whenever you commit something, Git stores it in the form of snapshots, unlike other version control systems. So assume that you have a directory with 2 files. When you stage these 2 files, Git creates a checksum for these files and stores that version in the repository. The checksum is the same 40-digit alphanumeric string that we talked about in the previous video. If you'll see here, I've used a shorthand for these checksums. When you commit the stage changes, Git checksums each subdirectory as well and stores them as a tree object in the Git repository. Finally, Git creates a commit object with metadata related to the commit, like the author name, the commit message, or even pointers to the older commit. The tree object that was created in the previous step will now point to this commit object so that Git can recreate the snapshot whenever needed. This block right here, by the way, is what I mean by snapshot. If you make any changes to this and commit again, this new commit now will store a pointer to the older commit. Now a branch in Git is simply a movable pointer to one of these commits. The default branch name for the most part would either be master or main. This master branch will point to the most recent commit. Every time you commit, this master branch pointer moves forward automatically. Now you can also create new branches. You can create a new branch by typing in git branch followed by the name of the branch. Creating a new branch essentially creates a new pointer for you to move around. So as I said, the default master branch will point to the most recent commit that you have made. Now when you create a new branch, a new pointer also points to the same topmost commit. Let's assume we create a branch called feature A. Now the way Git knows which branch you are currently on is through a special pointer called head. For now, this head pointer points to the master branch. The git branch command that we use to create a branch only creates the branch. To switch to that branch, you'll need to use the checkout command. When you do that, the head pointer points to the new branch. Now whatever changes and commits that you'll make will be privy to this branch. The master branch has no clue of what's happening. So say I make a commit in this feature branch, the branch now points to the topmost commit, and in turn, the head has moved one step further. So the master is essentially one commit behind this feature branch. This is interesting because if you switch back to the master branch now, the changes from the feature branch that you have in your working directory will disappear. It won't remove the files, it just reverts the files back to the snapshot that the master was pointing to. Now any changes that you make in this branch will essentially diverge the workflow. So basically if you're working on 2 different things and they are part of 2 different branches, you can switch back and forth between the branches and merge them together whenever you are ready. The reason why branching in Git is so efficient as compared to other version control systems is because all we are dealing with is the 40-digit checksum. Creating a branch in Git is basically creating a file with the commit checksum in it. Traditional version control systems used to copy project files into separate directories, which could potentially take several seconds or even minutes depending on the size of the project. So this is primarily the reason why Git branching is pretty efficient. and Git actually encourages users to leverage branching as much as possible. Alright, so this was a short video explaining how Git branching works. In the next couple of videos, we'll be creating, deleting, updating, merging, and doing all sorts of things with Git branches. If you have any doubts or suggestions, you can put them in the comments, and yeah, I'll see you in the next one.